Righto, Year 12, I'm going to go through another one of these questions that a student has asked about. I'm going to look at question 10, which is this question here. So I'll just read through it, then I'll set it up. So an arrow, we're assuming it's fired from the ground, and we're going to have to take out the height of the person shooting the arrow. So let's assume for some reason that they're lying on the ground. So the arrow is coming from a set point. And it's fired at a velocity of 24 metres per second and aimed at a target 1 metre high, which is 35 metres away. Now we know that if someone was shooting an arrow and they were standing up, the target would probably be the same height, but we're not going to have that situation here. Also, they say that the air resistance is negligible for angles of projection less than 45. That sort of suggests that maybe we might be going to get two answers for this. At what angle should the arrow be fired, and we're using gravity as 10 metres per second. So let's set this up over here. So this is question 10. So what do we have? We're shooting an arrow. So we'll start here, and we're shooting this arrow. There's our parabola. But the target here is 1 metre high. So that's 1 metre. Now, what were our velocities? Well, it was 24 metres per second. And we've got to find the angle to hit that target. And that target, that's really badly drawn. Let's get rid of that. That target was 35 metres away. All right, let's go. So here we go. X double dash equals 0. X dash equals some constant. We know that when t equals 0, x dash equals, what was it, 24 cos of the angle. We know there's nothing else acting on it, so x dash will be 24 cos theta. Integrate again, x equals 24 t cos theta plus some constant, but we know when t equals 0, x equals 0, therefore c equals 0. Therefore, our displacement is x equals 24 t cos theta. Do the y double dash. They told us to use 10. Y dash equals minus 10t plus 24 sine theta. Sorry, some constant, but we know that's the constant it's going to be when when t equals 0, y dash equals 24 sine theta, therefore c equals 24 sine theta. I'm not going to do the substitution. You have done it enough to realise by this stage that that's what it's going to be. So y dash equals minus 10t plus 24 sine theta. Integrate again, y equals minus 5t squared, because I raised to the power and divide by 2, plus 24t sine theta plus some constant. We know when t equals 0, y equals 0, therefore c will equal 0. So my y is minus 5 t squared plus 24 t sine theta. So we've got to find this theta. And we look at this and we go, well, what do we know? We know that to hit the target, it's got to travel horizontally 35 metres. So we're going to find t when x equals 35. 35 equals 24 t cos theta. So t will equal 35 divided by 24 cos theta. And you're thinking to yourself, well, that hasn't helped me, but it has, because we can substitute that t in here and here. And let's see what we get. Okay. And what do we know at that time? We know that y equals 1 at that time. So 1 equals minus 5, 35 on 24 cos theta squared plus 24 times 35 on 24 cos theta times sine theta. Okay. Let's tidy this up a bit. So I get 1 equals minus. Now, if I do all that, if I do that multiplication, I will get 6125 over 576, that's what 24 squared is, times 1 on cos squared theta. My 24s are going to cancel, so I'm going to get 35, so plus 35, and sine on cos is tan theta. Okay, here we go again. 1 equals negative 6125 on 576. Now 1 on cos squared is sec squared theta plus 35 tan theta. Well, that came in handy. 1 equals minus 6125 on 576. But sec squared is also 1 plus tan squared. Oh, good. Now I've got my variable that I'm trying to find in tan. Okay, let's multiply through a bit, and we get 1 equals negative 6125 on 576 minus 6125 on 576 tan squared theta plus 35 tan theta. Well, it looks like I'm going to get a quadratic here. Yes, you will, because we knew that there would be 2 answers to this. Okay. So let's wrap it all up so I can get everything on one side. So I'm going to take everything over the other side. So I'm going to get 6, 1, 2, 5 on 5, 7, 6 tan squared theta. Taking that over. Minus 35 tan theta. I'm going to add that 6, 1, 2, 5, 7, 6. So plus 6, 1, 2, 5 over 5, 7, 6 plus 1. But that's 5, 7, 6 on 5, 7, 6 equals 0. So I brought everything over. So 6, 1, 2, 5. I could multiply by 5, 7, 6, might make it easier. Tan squared theta over 5, 7, 6 minus, but this is how my notes do it, 35. It's just calculator work anyway, tan theta plus 6, 7, 0, 1 on 5, 7, 6 equals 0. So now we're going to use a quadratic equation. So tan theta equals minus b, 35, plus or minus the square root. I'm going to have this big thing here, b squared. So 35 squared minus 4 times 6, 1, 2, 5 over 5, 7, 6 times 6, 7, 0, 1 over 5, 7, 6. Let's just make that square root sign a bit bigger. All over 2a, 2 times 6, 1, 2, 5, 5, 7, 6. Now that is just calculator work. Now when you do that, you'll get tan theta equals positive 0.37515, and you'll get tan theta equals 2.916279. You inverse tan them and you get theta equals 20 degrees and 34 minutes. And you inverse tan this and you get 71 degrees and 4 minutes. Now we need to take the acute angle, not the acute angle, they're both acute. We need to take the angle less than 40. The angle must be less than 45 degrees. Therefore, theta equals 20 degrees, 34 minutes. So there you go. That's that one.